Good morning to both of you. How are you guys doing?
Doing
Very
well.
well.
Could
Nice
you
weather in
please?
Seattle today.
Oh, you're both in Seattle, right?
Yeah.
Ah,
Yep.
okay. Same time zone. Could you please introduce yourself? Let's start with Beatrice. Who are you? What do you do at Microsoft?
I'm a cloud advocate at Microsoft, and my role focuses specifically on Azure ML, which is now my favorite Microsoft product. And I have a background in Azure machine learning, in machine learning, both in grad school and at work. So I've been doing it for a little while. So that's basically what I do.
Okay, cool. Eric,
And
what about you?
I'm Eric Boyd. I lead the AI platform team, so including fabulous products like Azure Machine Learning that B loves so much, as well as our suite of cognitive services, the work we do with OpenAI and all of the things like that.
Uh, First of all, Eric, we also need to thank you for joining us like every big event we organize. We really appreciate that you make time for us again. And I need
Always
to
happy to
ask
talk
you,
about
can I get some more
AI.
GPUs, please?
Sorry, what was the question?
I need to ask the question, can I get some more GPUs?
Don't make me update my sign.
All right. The keynote that you guys are going to give is Azure AI Innovations at Microsoft. Well, I would say the platform is yours. We're looking forward to learn more about what Microsoft is doing. Yes, good luck.
Great. Well, let me go ahead
Right.
and share my screen. So I just wanted to talk a little bit about, what we're doing with Azure AI and some of how all this stuff works and comes together, and talk about really how the mission, our work, the different services we have, and how we bind that all together with responsible AI. And so, without sort of further ado, maybe I'll just jump right into it. We love to start with this mission that Satya's laid out for Microsoft, this bold mission of empowering every person, every organization on the planet to achieve more. And within the AI platform organization, we think about, how does our mission really dovetail that? And, we have a mission statement, but put really succinctly, we see AI as changing the world, and we want to make sure that we can enable everyone to go and take advantage of that. And so we really see the impact that this is having on the entire planet as being really profound. And it's very exciting to see, but that's, AI is just really transforming so much. And so I wanted to spend some time talking today just to highlight some of the places we're seeing AI show up in different businesses and some of the cool things that you can do with the tools and technologies that we've got. But for us, it always starts with research. And so that's one of the things that Microsoft has been tremendously fortunate in. We have Microsoft Research is the leading AI research lab in the planet, really all around the world, thousands of researchers, lots of patents and papers, regularly pushing the state of the art in AI. And that state of the art, really shows up in a ton of different products and a ton of different fields where we've really been, getting to human parity, which is just a milestone that we choose in a lot of different areas, from, object recognition to image captioning to natural language understanding, really all across the board. And, one of the things that we really focus on in the AI platform team is how do we take these breakthroughs, which show up in a research paper, on often a sort of lab environment that's not particularly stable, how do we get that into our products and get that into hands of our customers and really use it to change all of the businesses that we want to impact out there? And so just to take one, image captioning, the paper was published in about March of 2020, saying, hey, we've got some new breakthroughs, and with these large language models and understanding images, we're at human parity in March of 2020, according to the benchmarks that we measured on. We got that into our products in the APIs in like 3 to 4 months later, basically taking the research model, hardening it, giving it all of sort of the Azure goodness, all of the things that people expect around enterprise readiness and stability and quality. And now it shows up in products like Designer, where in PowerPoint, anytime you sort of put an image in there, will auto caption the image for you, giving alt text for it if you don't bother to do it yourself. And so that type of turnaround time and that type of impact really, and it shows up in, not just in PowerPoint Designer, But PowerPoint Designer, what is it calling? It's calling the Cognitive Services API. So that same thing available to our third parties. And so we spend a lot of time thinking about how do we take this really rapid pace of innovation that's coming out of the AI research community and get that built into the products that we want to go and develop. And so when we think about Azure AI, we think about it really as this layer cake here. We're all built on top of the foundations of Azure. So we have access to the world's largest cloud supercomputer and all of the, GPUs and CPUs and everything that's available there. And at the base level is Azure Machine Learning. And so that's a tool that we'll talk a bit more about, but really helps you manage your models, deploy your models, manage the full ML ops lifecycle of them, train the models, get access to thousands of GPUs, manage the sort of the training iterations that you're going to need to go through. And so it really is the tool for helping machine learning scientists and developers build their models. And so the next layer up of the stack is our suite of cognitive services. And so these are models that we at Microsoft have built in vision, speech, language, decision, and of course, our new partnership with OpenAI, which is showing up increasingly in new and exciting services. So these are models that are really state of the art that you can call as a cognitive service, a web API directly. And it really simplifies the process of getting AI into products. For customers who they don't want to build the expertise and all of the training data needed to build a high quality speech model, they should just call the cognitive service and they can add speech recognition or text to speech into their products in a matter of minutes. And so making it really simple to do the things that you need and have the impact on your products in a really quick and easy way. Um, then the top level of our services is our scenario-based or applied AI services. And so the thinking here is to say, we've got a number of ingredients at the cognitive services level, but those ingredients are often used in some very common use patterns. And so let's make those common use patterns a bit more productized and easy to consume. So, just as an example, in the vision cognitive service, there's optical character recognition. So given, a sheet of characters, you can turn that into text. But what people usually want to do is not just turn it into text, but actually take a form that they have and get the key value pairs out of it and put it into a database. And so that's what Form Recognizer does, is it wraps the OCR process that we have in Vision, but makes it really simple for you to, quickly with a few examples, get a form recognizer that will recognize the form that you have and then enable you to extract the data and put it into the data stores that you need. And so making that very common use case very easy to do. And so that's how we think about the services at that layer. And of course, these services are really geared for the developers and data scientists. But at Microsoft, we serve a wide variety of users, so all the way through business users as well. And we integrate these services into other products across Microsoft to make them more easily consumable by anyone. And so from everything from Power Apps, which provides a low code, no code way to build applications, which can then call all of these different services, all the cognitive services through an AI builder layer, as well as, then we integrate these services into other products. So like Power BI can directly call and train models on Azure Machine Learning and can use the models that others have trained for you, all the way to the full suite of Microsoft products. These services show up all across Microsoft in Microsoft 365, Dynamics, and all across the board. And that's one of the things that gives our customers a lot of confidence is because Microsoft runs on AI. Like we build these services for ourselves and we use them for ourselves. Something you won't hear our competitors saying as much. The Office team builds all of their models directly on Azure Machine Learning. That's the tool that they use to build, train, deploy, manage all of their work. And so when they want to do something like predict the text that should appear next in a Word document or in an email, that's done on models that are built and trained using Azure Machine Learning. And all the way to Teams calls, we transcribe the text. And so you can turn on transcription, you can turn on translation, you can turn on real-time translation. That is calling cognitive services directly, the same ones that are available to our customers. And so when we can make these services this rich and this mature, I mean, Translator embedded in Edge has just millions and millions of users. And so to be able to trust on these services being called by these high-end services for Microsoft, that really gives our customers the confidence that these are services that are really enterprise grade. They're ready for the enterprises. because we've made the same bet on them. And so if we're trusting our business to it, we expect our customers should be able to trust their business to it as well. And so it's not just Microsoft that's transforming, it's really every industry. I sort of talked a little bit about this. We're seeing the power of AI just touch every single business and every process and everything that gets done out there in the world, which is really exciting to see. It's a great opportunity, even in a time now where we see some, economic pullback and companies are sort of reassessing like some of the investments that they're making and how they're thinking about it. AI is so often a cost saver for companies that those projects tend to be ones that they still want to go forward with, and they want to find ways to use AI because it can provide value and it can save them costs at the same time. Some of the things that we see, we've worked across almost every industry, right? In financial services, we'll work with companies on everything from detecting fraud to making better and easier forecasts for all the different dimensions that they want to work at. Retail, we can help personalize objects, items to each individual user using a personalizer or building custom models for people. Healthcare, there's a ton of work happening in healthcare, both through our partnership with Nuance, or our now company that we've acquired, Nuance, as well as sort of other companies that we partner with, across the spectrum. So all across the board, we just see these changes coming in industries, and I get asked all the time, I'm a company and I'm starting to get started in AI, and how do I really get moving and how do I get going with it? The helping people understand what are the use cases, what are the common areas that are really going to help their companies really move forward. I think that's a really important thing that, we as a company and as an industry need to help these companies figure out, because AI is going to be so transformative in all of the work that they're doing. So some of the most common adoption patterns that we see when we go and talk to these customers, these are just a few of the examples that we see, but a common pattern is knowledge mining. So this is the notion that companies have just amazing amounts of data in all of their documents, all across the enterprise, and it's usually locked up and hard for them to find. Sometimes it's not indexed, or maybe it's even, a PDF file that they don't have a text version of, and invoices that they have over the last decades. And so how can we use knowledge mining and Azure Search to really help crack open all of the insights that they have in their business to be able to get insights back out? And so an example is Icertis. We work with them. They're trying to track their compliance through their compliance costs through their supply chain, tracking all these different steps. They have all the different documents around it that to support it, but it was very hard for them to get insights into it. And so by using a knowledge mining solution on top of cognitive search, they were able to really get insights into how to do this effectively. We see a lot of business process automation. So I talked about the way we use Form Recognizer, the number of businesses that have paper forms that they need to process, and so we worked with the National Health Service in the UK, and they have all these documents that they needed to process for their prescriptions every month. And so being able to give them a way to really speed up the way that that's done both makes them much more effective, as well as saves them a ton of money because they can do these things so much faster. Machine translation is another really powerful area that we see. We worked with Volkswagen, and Volkswagen has documentation that they have in over 40 different languages, and so they were able to use machine translation to really cover the bulk of the translation needs that they had, only needing to sort of spot check and fine tune in a couple different places with human translators behind it. Again, tremendous cost savings for the company, as well as tremendous acceleration in their ability to go and get work done. Another interesting area is just how companies are finding data that's been locked up in things like their customer support logs. And so Allstate used speech transcription of their claim calls, all the customers calling in about the claims, and they both now use that to speed up what the claim processor is doing to sort of quickly get up to speed on, hey, what's going on in this claim, as well as they can get analytics on it. You can now run these large language models to understand what's being talked about inside of it, and really learn the ins and outs of it. So a lot of adoption across a tremendous number of industries. Really, the imagination of everyone is the limiting factor here of how much can be done. So very exciting to see. So I wanted to talk a little bit more about the suite of cognitive services and some of the ways that they can be used in your businesses. And so, the suite of cognitive services, speech, language, vision, decision, these are the sort of the core pillars that, really with a lot of richness and depth in them that are state of the art across the board, regularly winning competitions, head-to-head bake-offs. This is generally the best that you can do in these particular areas. And so what I wanted to do is play a demo where Xiaowing is going to walk through some of the use cases that you might see and want to use these really around the customer support area. And so I'll just go ahead and play that.
In Bank of Contoso, their support agents receive hundreds of letters and emails from their customers every day. Here, I have an example of a dispute email submitted by an unhappy customer with their banking experience. A dense email like this can be tough for agents to catch up quickly, which will impact agents' issue resolution time and their customers' experiences. To resolve this challenge, developers in Bank of Contoso quickly put together this app using document summarization in Cognitive Service for Language. It provides agents with two types of summaries: an abstractive summary to rewrite a long email within only a couple of sentences, and an extractive summary to highlight a couple of key sentences from the original email, just in case the agent wants to get more context. Now agents can easily identify the reported issues with key information from long documents and quickly respond to customers, classify, and create case records. Now let's move on to another use case of contact center. Let's say this same customer also submitted a picture of paper form for this issue. The form is handwritten with customer details, so it can often take agents a lot of time to manually input the data into the system. And it could also result in human error. This is where Azure Form Recognizer can help you. The best way to try this out is using Form Recognizer Studio. Let's try to analyze general document and upload the form. By simply clicking the Analyze button, Form Recognizer returns the extracted key value pairs in the form. With this, the agent's manual process can be completely automated, so their time is freed up to focus on engaging with more customers. Now the same customer also made a phone call to the Bank of Contoso contact center. Hello, thank you for calling the Bank of Contoso. How may I assist you today?
Hi there. The abuse of my credit card has really screwed me up. I've sent the dispute email, I submitted the form. How long do I need to wait until it can be removed from my account? Please help me, and I need this solved as soon as possible.
I'm so sorry this happened. Let me assist you on your credit dispute request. It seems the customer is very upset about this issue. At this point, customer service managers probably want to get timely insights from a support call like this. So let's see how NLP capabilities in Cognitive Service can help you. Let's try it out in the Language Studio. It now provides a guided experience for developers to quickly explore and apply call center analytics. Using the sample data provided in Language Studio, we can see, together with Cognitive Service for Speech and Language, a call recording can be automatically transcribed and analyzed with sentiment and PI detection. It also uses conversation summarization to recap the customer issue and the resolutions as discussed in the call. Language Studio also provides the sample code and the JSON output. So developers in Bank of Contoso can easily get started with the sample code and integrate all these AI capabilities into this app to analyze the customer call we just played. With all these insights, service managers can quickly identify which calls need more attention and understand the content of those calls without even listening to the entire recording.
Really powerful to see how all of that can come together. Really exciting to see all those capabilities show up, and that's a sample application, but really helps you envision the types of things that really could be done with it. And the cognitive services really are a great asset to get you started and get you moving with that. I want to move from cognitive services into Azure machine learning. As I said earlier, this is sort of the base layer that helps you, build, train, deploy your models, manage them, manage the data, monitor them, and really watch the full MLOps lifecycle of it. It's really a very comprehensive suite of tools and a really powerful set of things that you can do. But more than talk about it, B, I think you would probably be in a better position to just walk people through and show them all the amazing things they can do.
Thank you, Eric. I will do just that because today I'm going to be demoing a game. That's right, a game. So more specifically, we'll be looking at the code for a part of a rock, paper, scissors game that uses AI extensively. And this code uses my webcam to capture an image as I make a rock, paper, or scissors with my hand. And then it uses AI to classify that image. And if you've watched the Microsoft AI show, you may already be familiar with this app. So there are 3 parts in the development of this app. And in part 1, I'm going to be training the model locally on my machine. In part 2, I'm going to be training the model in the cloud using Azure ML. And in part 3, I'll be showing you a web app that we use to interact with the trained model. So let's just look at the code.
Let's start with step 1, where we'll be training the model locally. We're using a pre-trained ResNet 18 model. The inputs to our model are images that look like this for rock, this for scissors, well, you get the idea. And the labels for the images come from the name of the directory where they're located. We're using the PyTorch deep learning framework, the PyTorch Lightning package to reduce the amount of PyTorch code we need to write, and the MLflow open source package to log some parameters and metrics. I'll show you later how to look at these logs. We can run the training code by choosing the PL trainer launch configuration and pressing F5. Training takes a few minutes, so I use the magic of video editing to skip forward to the final result. You can see here that training was done over 7 epochs and achieved a very low validation loss and a validation accuracy of 1, which is perfect. We can look at our MLflow logs here. For example, let's look at our validation loss over the training epochs. Or instead, we can look at the nice UI that MLflow provides us to see the same information visually. I always like to test my models locally before I train them in the cloud, which we can do in this app by running the PL tester launch configuration. This tests our model using just a few images, so it should be pretty quick. And as you can see, our test loss is also very low and our test accuracy is 1. This is great.
Okay, so we saw how to train the model locally. And now in step 2, we're going to be seeing how we're going to be training that model in the cloud using Azure ML. And to use Azure ML, we generally have to create several Azure ML resources to be able to get things working in the cloud. And there are generally 3 ways of creating those resources. We can use the Azure ML Studio user interface if you prefer to use UI. You can write code using the Python SDK, or the third way is to use YAML configuration files and the CLI. And this is what I'm going to be showing in the next demo. This is the third option, using YAML files and the CLI. So let's look at that code.
Let's look at the YAML file containing the configuration for my data, which, as you can see, points to the location of my local data folder. I can upload this data to the cloud and create the corresponding Azure ML data asset by invoking the azml data create command in the CLI. Let's verify this using the Azure ML Studio. And there's our data asset. We need to create a few more cloud resources for our scenario to work. We could create each one individually in the terminal as I just showed you, but instead, we created a GitHub action containing all the CLI steps, which makes them much more easily reproducible. The GitHub action creates a job that runs my training Python file in the cloud, then it downloads the trained model produced by the job, then it registers the model with Azure ML, and finally it creates a deployment and endpoint we can use to query the trained model. Let's run it. I'll fast forward here. And when it's done, we can go to the studio and take a look at our training job. You can see here nice visualizations for the MLflow parameters and metrics we logged earlier. We can then go to the model section and see that our model was indeed registered in Azure ML. And finally, let's verify that our endpoint was created. And it was. Great. Now let's test the endpoint. Our input section is already populated with a test image, and our prediction is scissors, with really high confidence. Excellent. We're ready to move on to step 3, where we'll query our endpoint from within a web app. We're using an Azure static web app here, with an Azure function that does a post request to the endpoint we just created. Let's look at the web app running. I'll capture an image, and then I'll submit it. This triggers a post request, which passes the image I just captured to the endpoint and gets back a prediction, rock, which is correct.
And that's it. So we're making really good progress on our game. And as you saw, machine learning made it so much easier to achieve what we wanted to do. So thank you for watching, and back to you, Eric.
Thanks a lot, B. Really cool demo. Yeah, rock, paper, scissors. Obviously not the most advanced AI game, but pretty cool to see how you can use AI in lots of different places. So thanks so much for walking us through that.
Baby steps, right? You can't do a big game before you do a little one, right?
You got to be able to do rock, paper, scissors before you can do tic-tac-toe, right? We're building our way up. So, so yeah, so next up, I wanted to walk through some of the things that we've seen coming with OpenAI. Really, there's been a transformation in the way that models are getting done, where it used to be a single, simple model just built for one purpose, to now we're seeing these large foundational models that are really generalized to a lot of different approaches. And we've seen the rate of growth in these models just exploding. I mean, GPT, which was released in 2018, to GPT-2 to GPT-3, and just really exploding the number of parameters. And the reason we're seeing so much growth in it is because the performance continues to improve as you make the models bigger, which has been really exciting to see. So we partnered with OpenAI, and with them, we've made GPT-3 available, a very large model used, generating lots of words every day with lots of different apps using the things that you can do on it. Very powerful AI, particularly in the, very powerful natural language modeling and understanding model. And so really great to see that used. We also used it to build GitHub Copilot, which instead of being trained on just English and language was trained on code as well. And so Copilot, as I'm sure most of you are aware, given a sort of a comment about, hey, here's what I want to write, and a function header, then you can generate the entire code. And we're seeing developers have, up to 30% of their code check-ins come just directly from Copilot. So tremendous efficiency being unlocked. We've also, with OpenAI, we just released DALL-E 2, which is now available in Azure OpenAI Service. And DALL-E 2 is a model where you can really take the text to get a model out of it. And so for someone who's not very artistically inclined like myself, you're able to get a lot of really interesting things done, and it's been integrated into Microsoft Designer, a product in PowerPoint, where you can see that DALL-E 2 is integrated directly right in it. And so what you do is you come up with the image, the background that I really want in my PowerPoint, and I just describe it. I want a Van Gogh of a bear eating a pizza in a restaurant. And you ask DALL-E to generate it, and it generates these really fantastic images that you can then sort of select which of these images do I want, and use that for the base of my PowerPoint style and how I really want to develop and use that. But of course, all of these things need to be done in a responsible way. There are lots of things that you can imagine that could cause challenges with this. And so we've spent a lot of time thinking about responsible AI, really based around the core principles that we have, and making sure that we're developing our models responsibly, reliably, safely, transparent, private, secure. Those are all the things that we really ingrain into our developers. And we provide tools as well. We recently released the Responsible AI Dashboard, which is a collection of tools that helps you understand things like error analysis. Where in my model am I having error? Being able to look at different cohorts, being able to look at the statistics against some of these different cohorts, being able to do, fairness assessments against the different, slices and things that you may want to look at, being able to do interpretability or counterfactuals, really understanding all the different things that can happen. It's a really powerful tool and really helps our internal developers as well as our third-party developers using Azure Machine Learning really make sure that they're building models in a responsible way across the full suite of applications that they manage. So those are the key things that I wanted to hit on. I know we're pretty late on time, so I don't know if we have too much time for questions, but really, thanks for the opportunity, and excited about all the wonderful things that are happening in AI these days.
I think it was a really great session already, Eric. Microsoft is really doing a great job in adding so many extra services. I really love it how it's also get built into the end products of Microsoft, like we saw in Dynamics 365, in PowerPoint with the designer, or in Teams and all these things. And then bring it all the way to the software developers to bring in their own AI when you don't have any AI skills, and then all the way for the data scientists, which is really all the steps, which makes it really nice. So
People
Yeah, no,
finally
we
are
think
going
about
to
all that
use it.
things.
Yeah,
Right? Yeah.
everyone can use it, and that's
Yeah.
the great thing. It's democratizing AI, and I think that's what Microsoft is trying to do.
And that is a good thing. Yeah.
Yeah, exactly. Eric and Beatrice, we're looking forward to having you also in the panel discussion in half an hour. So
Yep.
thanks already for joining us now, and we'll see you in a bit again.
Thank you so
Sounds
much.
good.
Thank
All
you.
right.
Thank
We will
Bye-bye.
be gone for a couple of seconds, and
Bye.
then we'll be back with our next keynote.